Hi class. So what we're going to look at now is some of the stoichiometry problems that you guys did in Gen Chem. So this is probably a review, but I figured since we'll still use this in lab, I wanted to take a chance to kind of highlight it. So the first thing is, you want to figure out what the problem's asking you. And so what it's telling you is you have 6 grams of carbon. So we have our carbon, 6 grams of it, and an excess of hydrogen. So that tells us that this will never be our limiting reagent. So we only have to care about when all the carbon's used up. And we want to find out how much methane it can produce. All right, so we're going to take our hydrogen and our carbon, add the two together, and we get methane. This one's a little bit easier because it's already been balanced, so make sure that you always balance the equation. And if there's no number in front, it's implied that it's 1. So it'd be 1, 2, and then 1 again. All right, before we get started, one thing I kind of wanted to highlight is our general idea, if we're starting with grams, is that we're going to go from grams of our starting material to moles. And remember, this will be moles of our starting material. And then also again to moles, but now this will be moles of our product, and then again to grams. And in this case, it's asking for our product. So the reason I want to highlight this is going to help us, if we're not sure how to get started with the problem, kind of give us a roadmap. So we're given grams, so we're going to start with our grams. We're going to get to moles of our starting material. Then we've got to somehow convert them from moles of starting material to moles of product, and then finally to grams. All right, so let's give it a try. So I think the best thing is to just start with what we know. So we have 6 grams, and it's 6 grams of carbon. I think that's important because we've got to know what we're working with. Now, if we want to go from grams to moles, we want to use our molecular weight. All right? And so in order to get to moles, we want to divide. So it's going to be 1 mole of carbon by 12 grams. All right? And so we got this from the molecular weight. Right? So the molecular weight of this is 12 grams per mole. And that's how we know that we had to divide, because we want moles on top. So whatever we're trying to get to needs to be on top. All right, so now our unit of grams will cancel out. All right, now the next thing we want to do is, in order to go from 2 different moles, right, so we're in moles of starting material and moles of product, that's where our coefficients become important. So let me highlight these. So for carbon, it's 1. For hydrogen, it's 2. And we always want to put what we're trying to... So let me do one more color. I'll use this obnoxious yellow. Methane in yellow. All right, so we always want to put what we're trying to get to on top. So in this case, it's methane. So we're going to put 1 mole of methane over 1 mole of carbon. All right, and I know in this case, since they're 1-to-1, they actually would cancel out. But a lot of times this isn't the case, so it's a really important step. And what this step is going to let us do is cancel out the mole of carbons and switch us to the moles of methane. So what it's giving us is, here we're using the mole ratio. And we always get that mole ratio from our coefficients. So that's why it's really important to balance the equation. All right, and then the last one is we just going to use the molecular weight again, but this time of our product. All right, so this one was of our starting material, so now we've moved to our product. So we can add up the carbons, right? So this one was easy because it was just a carbon atom, so that's where we get the 12. If it's a full molecule, that's okay. We just add up the pieces. So carbon is 12. Each hydrogen is 1, so it'll be 1 times 4, right? Because we have 4 hydrogens. So 12 plus 4 equals 16. So our molecular weight is going to be 16 grams over 1 mole of methane. Right? And this time, we want to put the grams on top because that's what we're trying to get to. Right? So here we divided because we wanted to get to moles, so that's why the moles would be on top. Here we wanted to get to grams, so that's why the grams is on top. Right? And so now, even before we punch in all our numbers, we can check the units of grams cancel out at the beginning. It leaves us in the unit of moles, right? And we want it to be in moles of carbon, just like our little pathway up here. And then we look, those cancel out, and now leave us in moles of methane. We eventually want to get to grams, so those cancel out, and we're left in the moles of in the unit of grams. And now if you punch all of this into your calculator, you should get that we get 8 grams of methane. All right, I hope this was helpful. One last thing before we go is I do want to highlight that this one only gave us one of the reagents and said the other one was in excess. Here in a little bit, I'll show you guys another problem. But if you're given both grams, so the grams of carbon and the grams of hydrogen, you essentially have to do what we did down here twice. We'd start once with carbon, and then we'd solve the same thing for hydrogen. And so if you're given both grams, you just have to do this twice, and whichever one gives you the least amount of product is going to be the right answer. And we'd call that our limiting reagent, because we'll use that one up first. The nice thing when you see the term excess is we're already telling you that the carbon is the limiting reagent. And so we only have to do this once. So if you're given both grams or the molecular weight of both of your starting materials, then you have to do this reaction scheme twice and see which one gives you the least amount of product, and that's the correct answer. All right, I hope this was helpful.